For nearly a decade, NASA had no choice. Every American astronaut heading to the ISS cost up to $90 million per seat, paid directly to Russia. Over $4 billion transferred while Roscosmos held complete control of access to space. Then SpaceX changed everything with 120 launches that destroyed a decade-long monopoly. How did launching more rockets break Russia's grip on crew transport? Let's dive right in. SpaceX operates from two launch pads in Florida, Launch Complex 39A at Kennedy Space Center and Space Launch Complex 40 at Cape Canaveral. These pads sit just 12 kilometers apart, and both are fully certified for human spaceflight. LC-39A is the historic pad that launched Apollo missions and space shuttle flights. SLC-40 was completely rebuilt after a Falcon 9 explosion in 2016, then upgraded specifically for crew missions. If one pad goes down for inspections or repairs, SpaceX simply moves the launch to the other pad within days. This redundancy completely changed the game. Crew rotations to the ISS run on a strict 6-month schedule, and missing a launch window doesn't just delay one flight, it disrupts crew handovers for months. Russia doesn't have this flexibility. Soyuz launches depend on a much smaller number of crew-certified pads at Baikonur Cosmodrome in Kazakhstan. When one of those pads is offline, there's no backup ready to take over. In recent years, this created launch gaps where the Soyuz spacecraft was ready, crews were trained, but launches couldn't proceed because the ground systems were unavailable. SpaceX built a system where pad failures don't become mission failures, and that operational resilience became the foundation for everything that followed. But infrastructure alone didn't break the monopoly. The real shift happened when NASA's costs dropped by 40% overnight. During the 2010s, NASA paid Roscosmos between $70 and $90 million per Soyuz seat. The price climbed steadily because Russia knew NASA had zero alternatives. By the end of that decade, more than $4 billion had flowed from American taxpayers to Russian launch operations. That revenue stream supported Roscosmos infrastructure, funded operations, and subsidized other programs for nearly a decade. Crew Dragon changed that equation immediately. A seat on Crew Dragon cost NASA roughly $55 million, and every dollar stays inside the U.S. aerospace industry. For Roscosmos, losing Soyuz seat sales eliminated one of its most stable income sources. The impact wasn't just NASA's savings, it was what happened next. That lost revenue directly affects Russia's ability to modernize its launch systems. Infrastructure upgrades slowed. New spacecraft development faced repeated delays. The Orel crew vehicle, Russia's planned Soyuz replacement, has been pushed back multiple times. Meanwhile, SpaceX kept accelerating. In 2023, SpaceX launched 98 rockets. In 2024, that number held steady at 96. Then in 2025, SpaceX pushed past 120 launches as Falcon 9 missions ramped up to support Starlink, NASA contracts, commercial payloads, and crew flights. That's a 25% increase year over year. For 2026, internal targets point toward 170 launches. If SpaceX hits that number, it would average one launch every 2.1 days for an entire year. The scale is unprecedented. Roscosmos launched 19 times in 2024. China's entire space program, including all commercial and government launches, reached about 60 flights that same year. SpaceX alone is outpacing entire nations, and this isn't just about bragging rights. High launch cadence creates engineering feedback loops that accelerate improvement. Every flight generates data. Every recovery refines the process. Every payload integration builds institutional knowledge. Russia can't compete at this pace because the infrastructure and financial foundation required simply doesn't exist anymore. Since 2020, SpaceX has flown multiple Crew Dragon missions per year, each carrying 4 astronauts. Several of these flights included Russian cosmonauts under seat swap agreements with Roscosmos. These agreements exist for one critical reason. Both the United States and Russia want guaranteed continuous presence on the ISS, even if one side's spacecraft is grounded. When Crew Dragon lifts off, the capsule reaches orbit in about 9 minutes and docks with the station roughly 19 to 24 hours later, completely autonomous, no manual piloting required. That reliability is exactly what ended Russia's leverage. While Falcon 9 dominates current operations, SpaceX is already building something far larger. Starship stands approximately 120 meters tall when fully stacked, more than 10 meters taller than the Saturn V. At liftoff, the Super Heavy booster generates roughly 7,400 to 7,600 metric tons of thrust from 33 Raptor engines. The Starship upper stage adds 6 more Raptor engines, bringing the total to 39 engines per launch. No rocket in history operates at this scale, and the payload capacity is what makes this revolutionary. In reusable mode, Starship is designed to carry 100 to 120 metric tons to low Earth orbit. Falcon 9 maxes out at about 22.8 metric tons. Falcon Heavy in expendable mode carries around 63 metric tons. Starship more than doubles Falcon Heavy's capacity while aiming for full reusability. If SpaceX achieves even half of Starship's target performance, the economics of spaceflight change permanently. A single Starship could replace multiple Falcon 9 launches, driving costs down even further. In 2025, SpaceX flew multiple Starship test flights that demonstrated full-duration booster burns, hot staging separation, controlled booster descent, and upper stage re-entry at orbital velocities approaching 7.5 kilometers per second. For 2026, regulatory filings indicate SpaceX is targeting 20 to 30 Starship launches, more flights in 1 year than the entire program has conducted since its start. But 2026 won't just be about volume. SpaceX is transitioning to Starship Block 3, incorporating structural, thermal, and propulsion upgrades designed for repeated reuse rather than experimental data collection. Block 3 Starships features stretched propellant tanks that increase total fuel load and improve payload mass to orbit. The most significant upgrade is propulsion. Block 3 uses Raptor 3 engines, which generate roughly 280 to 300 metric tons of thrust per engine, up from about 230 tons on early Raptors. External plumbing has been removed, part count reduced, and manufacturing processes streamlined. This lowers weight, reduces failure rates, and allows SpaceX to produce engines at higher volume. Raptor 3 is designed for rapid reuse, not refurbishment-heavy turnaround, and SpaceX is already preparing Flight 12, expected to be the first launch incorporating major Block 3 elements. Of course, operating at this scale comes with risks. The Starship launch earlier this year that ended in mid-flight explosion wasn't just another test failure. Newly released FAA documents reveal what actually happened. Starship Flight 7 launched in January was destroyed less than 10 minutes after liftoff. When the vehicle broke apart, it scattered a massive debris field across Caribbean airspace, directly intersecting with busy commercial flight corridors. At the time of the explosion, 2 commercial passenger jets and 1 private aircraft were flying through the region, carrying around 450 passengers combined. One pilot declared Mayday 3 times and made an emergency diversion to San Juan. All aircraft landed safely with no injuries, but the incident exposed a critical gap. According to FAA findings, SpaceX did not immediately notify air traffic control through the official emergency hotline. At breakup altitude, Starship travels at several kilometers per second, and debris doesn't fall straight down. It spreads laterally across hundreds of kilometers. That's why fragments threatened aircraft far from the launch corridor. This tension between rapid iteration and operational safety will define whether Starship can transition from test program to operational vehicle. The FAA now requires enhanced debris tracking and stricter coordination protocols for future flights. SpaceX's ability to maintain high launch cadence while meeting these new requirements isn't just about following rules. It's about proving that this new model of spaceflight development can work at scale without compromising safety. The stakes are higher now because the world is watching, and Russia's monopoly didn't just end because SpaceX launched more rockets. It ended because SpaceX built a system that works better, costs less, and delivers results consistently. The numbers tell the story. Russia spent a decade charging $90 million per seat with no competition. SpaceX entered the market at $55 million and launched over 120 times in a single year, while Roscosmos managed just 19. That's not just winning a contract, that's fundamentally reshaping who controls access to space. The $4 billion NASA used to send to Russia now flows into American aerospace, funding the next generation of spacecraft, while Russia struggles to maintain what it already has. But this shift goes deeper than launch counts or cost savings. SpaceX proved that high-cadence operations, infrastructure redundancy, and aggressive development timelines can coexist with crew safety. Starship Block 3 with Raptor 3 engines isn't just an upgrade, it's the vehicle that could make the cost difference between SpaceX and everyone else even wider. When a single Starship can replace multiple Falcon 9 launches, the economic gap becomes impossible to close. The Flight 7 debris incident reminded us that moving this fast carries real risks. But SpaceX adapted, the FAA tightened protocols, and the program continues. That's the model now. Iterate, fail, learn, improve, repeat. Russia's monopoly didn't end because of one breakthrough. It ended because SpaceX built a system that gets better every single launch. If you want to stay ahead of every major development in space technology, hit that subscribe button for Space Update 24 hours. Drop a comment on what you think comes next for Starship, and share this video with anyone who still thinks the space race is over. Thanks for watching, and I'll see you in the next one.